Testing every light and outlet during the rough-in stage of electrical installation is a critical practice for ensuring safety, code compliance, and overall quality. While it's difficult to quantify exactly how many electricians follow this practice meticulously, understanding the reasons behind it and the proper procedures is essential for anyone involved in electrical work. Firstly, safety is paramount. Energizing circuits before all connections are properly made and grounded can create significant hazards, including the risk of electrical shock, fire, and equipment damage. Testing during the rough-in stage allows electricians to identify and correct potential problems before they become dangerous. Secondly, code compliance is mandatory. Electrical codes, such as the National Electrical Code, or NEC, specify requirements for wiring methods, grounding, and overcurrent protection. Thorough testing ensures that the installation meets these requirements, avoiding potential violations and costly rework. Thirdly, quality control is enhanced. Testing during rough-in allows for early detection of issues such as miswired outlets, short circuits, and open circuits. Identifying and correcting these problems early in a process saves time and money by preventing them from becoming more complex and difficult to fix later. Now let's consider the specific aspects of testing lights and outlets during rough-in. For lighting circuits, it's crucial to verify the continuity of the wiring, ensuring that there are no breaks or short circuits. This can be done using a multimeter set to the ohms function. Measure the resistance between the hot and neutral conductors. An open circuit will show infinite resistance, while a short circuit will show very low resistance, close to 0 ohms. Another important test is to verify the presence of a ground connection. Use a multimeter to measure the resistance between the hot and ground conductors. A low resistance reading indicates a proper ground connection. For outlet circuits, it's equally important to verify wiring continuity and ground connection. Use a multimeter to check the voltage between the hot and neutral conductors. With the circuit breaker turned off, the voltage should read 0 volts. Then turn on the circuit breaker and check the voltage again. It should read approximately 120 volts in a standard residential circuit, or 277 volts in many commercial circuits. Always verify the voltage is correct for the intended application. Next, test the polarity of the outlet. Use an outlet tester to ensure that the hot, neutral, and ground wires are connected to the correct terminals. A properly wired outlet will show a green light indicating correct polarity. A miswired outlet will show a different light pattern indicating a wiring error. Correct any wiring errors immediately. Now let's talk about testing recessed can lights. Recessed can lights require special attention during testing due to their design and location. Firstly, ensure that the can lights are properly installed and secured. Check that the mounting brackets are securely attached to the ceiling joists and that the can is properly aligned. Secondly, verify that the wiring connections are made inside the junction box according to code. The junction box should be securely attached to the can light housing. Thirdly, test the wiring continuity and ground connection, similar to testing standard lighting circuits. Use a multimeter to check for short circuits and open circuits. Ensure that the ground wire is properly connected to the can light housing and the junction box. Fourthly, check the insulation clearance. Recessed can lights generate heat, so it's important to ensure that there is adequate clearance between the can light housing and any nearby insulation. Follow the manufacturer's recommendations for insulation clearance. The use of IC-rated can lights allows for direct contact with insulation. Testing procedures may vary depending on the specific type of can light and the manufacturer's instructions. Always refer to the manufacturer's instructions for specific testing procedures. In addition to using a multimeter and outlet tester, other tools can be helpful for electrical testing during rough-in. A circuit tracer can be used to identify specific circuits and wires. This can be particularly helpful when working in complex electrical systems. A ground fault circuit interrupter, or GFCI tester, can be used to test the functionality of GFCI outlets. GFCI outlets are required in wet locations, such as bathrooms and kitchens. The GFCI tester simulates a ground fault and verifies that the outlet trips properly. Proper testing requires a systematic approach. Firstly, start by turning off the circuit breaker that supplies power to the circuit being tested. This is essential for safety. Secondly, visually inspect the wiring and connections. Look for any signs of damage, loose connections, or improper wiring. Thirdly, use a multimeter to test for continuity, short circuits, and open circuits. Fourthly, use an outlet tester to verify the polarity of the outlets. Fifthly, test the ground connection. Sixthly, document the results of the testing. Keep a record of the testing procedures and the results. This can be helpful for troubleshooting and for future reference. It is very important to follow safety precautions during electrical testing. Firstly, always turn off the power before working on electrical circuits. Secondly, use insulated tools. Thirdly, wear safety glasses and gloves. Fourthly, never work alone. Fifthly, if you are not comfortable working with electricity, hire a qualified electrician. Failure to follow safety precautions can result in serious injury or death. Code compliance is a critical aspect of electrical installations. The National Electrical Code, or NEC, provides detailed requirements for wiring methods, grounding, and overcurrent protection. The NEC is updated every 3 years, so it's important to stay up to date on the latest requirements. Local building codes may also have additional requirements. It is essential to be familiar with the applicable codes and regulations. Common wiring errors to watch out for include reverse polarity, open ground, and short circuits. Reverse polarity occurs when the hot and neutral wires are connected to the wrong terminals. This can create a shock hazard. An open ground occurs when the ground wire is not properly connected. This can prevent the circuit from being properly grounded, increasing the risk of electrical shock. A short circuit occurs when the hot and neutral wires come into contact with each other. This can cause a fire. Addressing testing challenges is also important. Sometimes testing can be challenging, particularly in older buildings or in complex electrical systems. In older buildings, the wiring may be damaged or outdated. In complex electrical systems, it can be difficult to trace circuits and identify problems. In these situations, it's important to take a systematic approach and use the appropriate tools and techniques. When troubleshooting electrical problems, it's important to start by gathering information. Talk to the building owner or occupants to find out what problems they have been experiencing. Review the electrical plans and diagrams. Inspect the wiring and connections. Then, use a process of elimination to identify the source of the problem. Start by checking the simplest things first, such as the circuit breaker and the outlets. Then, move on to more complex components, such as the wiring and the electrical panel. Remember the importance of documentation and record keeping. Keeping accurate records of electrical testing and repairs is essential for several reasons. Firstly, it provides a history of the electrical system. This can be helpful for troubleshooting and for future reference. Secondly, it demonstrates compliance with codes and regulations. Thirdly, it protects the electrician from liability. Records should include the date of the testing, the procedures used, the results, and any repairs that were made. It should also include the name of the person who performed the testing and their qualifications. In conclusion, testing every light and outlet during the rough-in stage of electrical installation is a critical practice for ensuring safety, code compliance, and overall quality. By following proper testing procedures and adhering to safety precautions, electricians can identify and correct potential problems before they become dangerous. Testing also allows for early detection of issues such as miswired outlets, short circuits, and open circuits. Identifying and correcting these problems early in the process saves time and money by preventing them from becoming more complex and difficult to fix later. Always remember to consult the National Electrical Code, or NEC, and local building codes for specific requirements and regulations. Staying up to date on the latest codes and regulations is essential for ensuring compliance and safety. Electrical work can be dangerous, so it's important to take all necessary precautions. If you are not comfortable working with electricity, hire a qualified electrician. Finally, always prioritize safety and never take shortcuts. Electrical safety is everyone's responsibility. Testing every light and outlet during rough-in helps ensure a safe and reliable electrical system for years to come.